The next topic I want to cover is how we are applying generative AI in Vanderbilt courses. And I'll focus on the courses that I teach, but many of my colleagues, such as Jesse Spencer-Smith and Shiro and Jules White, some of whom you know, others of whom you will hopefully know, have been very eager to adopt the latest and greatest stuff. So my attitude on this is, rather than try to pretend like this isn't happening, rather than trying to pretend like we need to put our heads in the sand or be fearful, I've decided to stop worrying and embrace this technology and see what I can use it for in the classes I teach and how it can make me much more productive in what I do. I've been doing this sort of thing for a very long time. For the past 12 years, I've put all the lectures I've given at Vanderbilt online on my YouTube channel, and I've got 23,000 subscribers and millions of views, which is pretty cool. And so the point of this is that I was well positioned to leverage a lot of the stuff we're going to talk about because I had a lot of digital content that could be part of what I'm going to discuss in the way I teach my classes. So I've been applying these technologies in several of my courses that I teach. Pretty much anything I teach now, I find a way to leverage this. One of the courses I'm teaching right now involves building mobile cloud computing applications so you can have your Android device talk to various microservices running in a cloud environment, and we're showing off all kinds of cool features with respect to synchrony and asynchrony and concurrency and parallelism and persistence, and it's really lots of fun. So as a simple example, some of the classes I teach have people building a movie recommendation system using web-based technologies with some parts that are AI-enabled, some parts that are more classically enabled, and it's giving us a real chance to play around with this stuff, not only from the development point of view, but also from the operational point of view. The courses I teach at Vanderbilt are mezzanine courses. You know what that means. It just means that graduates and upper division people can take them. That makes a lot of things easier because I don't have to be as concerned with trying to figure out how to teach this technology to introductory programming classes, where it's a lot dicier because we really don't want to encourage people to completely outsource their brains from a programming and computational thinking point of view to an LLM yet. We want them to build some muscle memory, some foundations that will help them, even if they don't end up programming for real down the road. We want them to understand how you build systems and you debug systems and you break systems up into pieces. Those are important problem-solving skills. When I teach classes, there's a bunch of things I really like to do, and there's a bunch of things I don't really like to do, but I have to do, because otherwise the course doesn't work. So I like to give lectures, I like to make slides with pictures on them. I like to create examples and walk through the examples in Java or C++. I like to make programming assignments. I like to look through my students' code and find ways to give them tips on how to improve it. Those are the fun things. There's a bunch of other things I have to do. I don't like making tests. I don't like making quizzes. I don't like making knowledge check questions. I find that boring. I don't like to grade the final assignments because it's depressing, because people will sometimes not take my comments into account, and so then we have to mark them down. And I also don't like to have to try to write the summary comments describing the videos that I produce. So in any given class, I'll typically have a half dozen videos. I like to talk, but gosh, later on, I'm like, what was the point of that video? I don't even remember what I talked about. So those are things that are not much fun. So what I've been doing is using augmented intelligence to accentuate the things here on the left that are fun and do a good job of doing the things on the right without me having to spend a lot of time on it, but I can still have good outcomes. So it's about making me more creative and more productive. So let's start off with some things having to do with lecture material and quiz and exam assessments. So what I do now is I use augmented intelligence, ChatGPT 4 with some other things, to improve the online material for my classes as well as the quizzes and exams that I give. And how do I do this? Well, one thing that I do in a lot of my videos is I create knowledge check questions. And the idea is at the end of every video or end of every part of a lesson, there's a set of questions, and in class we'll discuss them and people will vote on what the right answers are. I hate writing those things. So what do? I will take my slides and I will give it to ChatGPT and I say, please read this PDF file and generate multiple choice quiz questions with 4 options related to the primary objective of whatever it is we discuss. And it will come up with some really good questions. And then, of course, it'll also say what the correct answers are. So that's a nice way to have it do the work that I could spend a long time and not be very edified doing, but it'll come up with really good things because it reads the material I produce and then comes up with insightful questions. Pretty cool. That's basically what's known as in-context learning. Another thing I love to do, I have all these videos at the end of every day, and I upload them to YouTube. I unlist them at first, and then once they've created the transcripts for the video, I then use this tool called GLASP, which you can get here. And when you click on the GLASP tool, it's a plugin to Chrome, it will go and take the transcript of your video and then summarize it. And then I will go and I'll say, please generate a 100-word paragraph summary of this video from the transcript. And boom, it'll create the video transcript, and it'll create the description, the summary. And then, of course, I go through it quickly just to make sure it's correct, and I get rid of passive voice. It actually generates very good summaries of things. And these are my words originally, so I'm just refining my words without having to spend my time trying to figure out what the key points were. Great way to do stuff. Something else I like to do is I like to create my quizzes and exams based on the lecture material from my courses, which has a couple of important side effects. Number one, it encourages people to come to class. And number two, it encourages them to leverage the technology to practice for the quiz. So what does that mean? So what I'll do is I will create quiz questions that I have in my online or Blue Book style quizzes, and I will get them from asking questions through the ChatGPT plugin for GLASP in Chrome. And students can leverage this stuff to study for the quizzes. So if they want to know like what might be on the quiz, I say, go to my videos, which are all on my YouTube channel, click on GLASP, get the transcript loaded in, and then quiz yourself on the assignments, or quiz yourself on the material covered, and see how well you do, because chances are those are the kind of questions that are going to show up in the quiz. This ability to have no or low cost, around-the-clock tutoring on demand is absolutely transformational for education. And a good place to look for more information about this is Sal Khan. He's the founder and CEO of Khan Academy. And he's got a nice video that talks about how they're building generative AI tools that will help save education rather than destroy it. And I totally believe that perspective. So these are all ways you can use these tools to make yourself more productive as a teacher and make the experience more productive for the students, because they can study in conjunction with these tools and get very good responses. And by the way, the nice thing about using it this way, it's working off of the transcripts, so it doesn't tend to hallucinate. It keeps it within the confines of what was in the lecture, which of course are where my lecture quiz questions come from. Next topic, another thing that I like to do, but I have not been able to scale up until recently. So one of the things I learned at the beginning of the fall semester was that augmented intelligence can generate the solutions to many programming assignment specifications. And I won't go into this in great detail. You can look at this link here if you want to see this transcript. But I was working with one of my colleagues at Vanderbilt CS, and he has a very hard assignment in his data structures course, which is sort of the second level course that you would take as a CS major. And I said, hey, do you think we could see if ChatGPT could generate the solution from your spec? And to give you the Cliff Notes version, yes, it can. And I was like, wow, that's pretty alarming. That's pretty disruptive. But I thought to myself, gee, my courses are advanced courses. It's much harder to do that. So I went, this was like the day before the fall semester. So I went back and tried it on my assignment I was about to put out. And lo and behold, it could generate a solution that was very close to what I would expect someone to do. At which point it was a real problem for me, because I didn't want students to just mindlessly generate the solutions. So at that point, I had to think carefully about how to create programming assignments that were difficult to use ChatGPT to auto-generate solutions. So of course, I asked ChatGPT how to do that. And it gave me some good answers. And one of the main things it said was essentially make your specifications less specific, make them more general, which is good. You're not giving people as many hints, which means that the AI can't generate solutions using those hints. Well, this was good at one level, but it was harder now because it became more difficult to assess the output from the students, because they were no longer following the Procrustean bed of the original specs that were much more tightly constrained. Historically, I've had auto-graders for my programming assignments that do very sophisticated mocking, where they look at the implementations the students make and then determine if they are correct or not. But when you start giving looser specs, it's harder to check things in that manner. And there's also some other challenges with mocking frameworks that they only look at things that can be mocked and not everything can be mocked. The second problem we have, and this is something if you've taken CS 101, for example, or 1101, you know that the way we address these issues historically is by having an army of TAs or graders that grade things based on a rubric. And that's how we try to scale stuff up when we get large classes. Not a bad solution, but one of the problems you suffer from is something known as the inter-rater reliability problem. And you see this all the time when you watch the Olympics, and you'll have figure skating or gymnastics, and back in the day, the Soviet Union would score their athletes high, and the US judges would score their athletes low, and then vice versa. When it was US athletes, the US would judge them high, and the Soviet Union would judge them low. So you have this problem with easy and hard graders. So how do we address this issue? Well, there's lots of good things that come from what I'm about to talk about, because we're moving away from highly prescriptive specifications to things where you give people more creativity in how they provide solutions that we can then assess. And of course, the solution here is going to be applying augmented intelligence, in our case, a private version of ChatGPT. Now, my courses that I teach in CS are very unusual. At least I think they're unusual. Most other people don't do this. So when students submit their assignment, I review all the assignments. I give them feedback, push it to their GitLab account. Then they have a few days to revise their program. They resubmit their program, and then the TAs and graders give them the final score. So at least in theory, if people are willing to work hard and follow directions, they should do very well. Not everybody does that, but that's a different issue. So this is what we know as discrepancy analysis. I am looking at student solutions, trying to identify the right solutions and the wrong solutions. And there's two dimensions. Sometimes people do things that are adding stuff that shouldn't be there, and sometimes people are doing things that should be there but they didn't add, or sometimes people put the wrong thing in. So there's a bunch of things I'm looking for discrepancies. So I'm going to focus here on the instructor review portion of this process and show you what I'm doing. So when I review all the students' code, people have a tendency to make similar mistakes. And so I will create, I've done this for decades now, I create something I call a frequently made mistake video, where I walk through and I say for each thing people do wrong, what the issue is, and I write it down in a file, and then I make a video that shows what the issues are and gives some hints on how to fix them. And I've done this for a long time. The problem, however, is between each offering of the course in every semester, there was no way for me to leverage my knowledge from before for the next class, other than just being smarter about what kind of problems to look for. So what I'm doing now is we wrote a tool together with one of my grad students who's been TAing my class for a while. And he parses this file, and he creates a JSON file that describes each of the frequently made mistakes in terms of what the mistake's title is, a description of the mistake, a correct example of what should be done, an incorrect example of what not to do, just pulling this out of my file here. And then we take that JSON file and we create a rubric that we can feed to ChatGPT. So we can give ChatGPT this rubric. And what we then do, and we'll see the rest of this stuff, is when the graders and the TAs do the final assessment, they don't have to try to read my mind. They don't have to be me. They just have to take a look at the output of what ChatGPT is doing via the discrepancy analysis based on this rubric that we're giving it. So we're basically training a custom fine-tuned model. I'm using the word model here loosely. We're giving in-context learning to ChatGPT. And then we can run the students' final solutions through ChatGPT, and it will identify the discrepancies. And we wrote a paper that was recently accepted at a workshop that talks about how this works. It's kind of cool. And that way the students can, or sorry, the graders can find very quickly where students have made mistakes in their final versions and then grade them accordingly. Now, what's interesting about this is that it's good 95% of the time. If you phrase things properly and you use the right version of ChatGPT with the amount of context that's appropriate, it's almost always right. However, there are situations where it's not correct. So what we do is the graders now go look at the output, find the areas where ChatGPT is saying this is a mistake, take off X points, and they double check it. That catches 99.9% of the problems. But of course, if there's something that gets through and we grade something incorrectly, the final sanity check is the student who gets their score back, and they're like, holy moly, had points taken off, but it's correct. And then we come back and we adjudicate that in office hours or over Piazza or whatnot. So the point is that using augmented intelligence, we can really drive the error rate to effectively 0, but we massively speed up the way in which the process works, which is very, very valuable, especially when you have a large class. The other thing that's nice about this is you can use ChatGPT iteratively to improve its accuracy. So if it's not quite catching the mistakes you know it should catch because you know what the mistakes are, because I reviewed the code originally, you can engage in a dialogue with ChatGPT and say, why didn't you detect this problem? How can I phrase my prompt better so that you will detect it the next time? And it will actually discuss that with you. It'll give you suggestions on how to improve the prompt. Good luck trying to do this with any other static analysis tool that's pretty much ever existed. You can't take other code analysis tools and engage in a dialogue with them to get them to tell you how to use them more effectively. If you go to your compiler, your Python compiler or your R compiler or your interpreter or whatnot, and you say, why is my program not compiling? Then your compiler will be like, that does not compute, that's a syntax error, because you can't engage. It's not meant to have a dialogue. So this is a really neat feature. The last thing I'm going to talk about here just very quickly is something else that's really important, especially when we start thinking about how to use these tools effectively for non-CS courses or non-CS application domains. So this is an example that came from a faculty meeting that we had for computer science faculty about 8 months ago or so. And this is a demonstration of how prompt engineering is a more effective way of problem solving than programming in the traditional way, because we can use natural language programming. So here were the steps that we had to do. So we had a faculty meeting and we wanted everybody to get a chance to have their voice heard. So we had 35 faculty. We said to them, send us a 1-sentence or 1-bullet summary of what you would like us to discuss in this meeting. So we got 35 responses. We then used ChatGPT to take a look at the responses and bin them up into 6 categories or so. So we had a bunch of categories, and they quickly fell into things that you would expect: academic and course programmatics, faculty and student development, those kinds of things. So now we had all the different topics binned. Then we sent those topic groupings to the faculty and said, please fill out a Google form indicating which of these different topics you want to be part of, and rank them from 1 to 6. So then we ended up with a bunch of preferences. And what we then did was we used ChatGPT to map the faculty and their preferences to discussion topic groups. So this is pretty much what it looked like. Said, here's the input from 35 faculty member and their top 3 preferences, ordered from highest to lowest out of a total of 5 topics, numbered 1 through 5. And I said, please generate output that allocates all 35 faculty members to all 5 topics, balancing them evenly, and I told them what that meant, taking their ordered preferences into account. And then I gave them a little bit of a sort of a few-shot prompt here that said, this is what the output, this is what the input looks like, here's what it means, and then I gave the list of faculty members. And what's fascinating to see when you look at this is what it did, and I actually have a link here, which I won't go through in the interest of time. But basically, what happened was ChatGPT first started to try to come up with an allocation, and it did a pretty good job, but because it used a greedy algorithm, there were a few faculty members, the ones who had been late to submit their request, so they were at the bottom of the list, who didn't get into a topic area that they cared about at all. So I then engaged in a little dialogue with ChatGPT, and through a couple of extra prompts, we worked together, me and my chat buddy, and we came up with a way to get the balanced topics where everybody got something they cared about. And what was interesting about this, there was not a single line of Python code or Java code or R code that I wrote. I wrote natural language prompts. But what was fun was that ChatGPT would show what it was doing under the hood. It would generate the algorithm it was applying and show you in Python code what the solution was. And it finally, on its own, came up with this approach that used a randomized way of being able to do the mapping and the allocation so everybody got what they wanted, even if it wasn't their first choice. So that was a really eye-opening example of using generative AI to solve a problem where traditionally we would have spent time writing a program, but it would have taken us days to get that program to work, whereas it took us minutes to problem solve. And this is something very important to think about, especially in other domains besides computing, where people don't want to write programs, they want to problem solve. So this sort of underscores the key point here that everybody is going to be a programmer. Everybody who uses large language models, that is, will be a programmer, but we're a natural language programmer programming large language models using English or French or Farsi or Swahili or whatever it is you think like or converse with, and that's how the programming is going to be done, or at least part of it will be done. All right, so that's the end of how we're applying it at Vanderbilt. There's lots more that could be said on this subject, but in the interest of time, I will wrap up.